So, hello everyone, welcome to our Ask Geology, a whole new way to understand our Mother Earth. So, in this today's 7-minute numerical, we will discuss about one conceptual question related to your ore geology, that is related to your microthermometry or fluid inclusion studies. Okay, fluid inclusion studies, that is microthermometry studies, that is used for the fluid inclusion studies. Okay, so this is actually a gate question as this banner suggests. Okay, so the question is, this is the question number 44, gate 2018. Okay, so two coeval primary aqueous biphase fluid inclusion, one is X, another is Y, and X is liquid rich, Y is vapor rich, occur in the same grain of the host mineral. Okay, there is one mineral. Okay, there is one mineral. Inside this mineral there are two fluid inclusions. Okay, two fluid inclusions, one is X, another is Y. One is your vapor rich and X is your liquid rich. Liquid rich, and this is vapor, this is your vapor rich. And this aqueous biphase fluid inclusion. Biphase fluid inclusion means vapor is there and liquid is there. Okay, biphase, these are two phases, vapor phase, liquid phase. Okay, and which of the following situation most likely indicate boiling of the fluid? Boiling of the fluid. Okay, if you just boil the fluid, sorry, if you just boil this whole system, then what will happen to these two inclusions? Okay, these fluid inclusions X and Y. So now these things, two is simple to coeval. Coeval means they are formed at the same time. Okay, they are formed at the same time. Okay, if they are just they have been formed at the same time of origin, then they will be called coeval. And primary, what this primary indicates? Primary is during crystallization, whatever the fluid inclusions that are being trapped, they are called primary. This is during. Okay, before or during the crystallization, whatever the fluid inclusion that are being trapped, they are called primary. Okay, primary fluid inclusion. During crystallization, better say during crystallization. Okay, so then what are the other types of then fluid inclusions? It may be primary, it may be secondary. Secondary means after crystallization, and it may be pseudo secondary. Okay, what are types of your fluid inclusion? One should be your primary. Okay, then secondary, then third pseudo secondary. Pseudo secondary. Okay, and biphase and polyphase, monophase. Monophase means only one phase will be there. Biphase means two phases will be there. In this case, that is liquid and vapor. And polyphase means, okay, polyphase means liquid, vapor, and some solid daughter crystal may be there in any fluid inclusion if it is highly saturated or super saturated with something. And another thing, this liquid and vapor, they can be, if this liquid and this vapor, you can see this is liquid H2O, vapor carbon dioxide, liquid carbon dioxide. So in carbon dioxide case, CO2 case, we are having both liquid and vapor. Another liquid water is also present. So this is carbonic inclusion, and it is actually a polyphase. Okay, no daughter crystal is there because maybe this might not be a very super saturated solution. Okay, and you can see this is aqueous biphase inclusion, where this vapor and liquid are the two phases present in the biphase. Okay, so what is vapor rich and liquid rich? You can see so many of liquid is present here in this biphase inclusion, so many of liquid, so we'll call it as a liquid rich. This is liquid rich. And if it would be a vapor rich, fluid inclusion, then how the diagram will be. Okay, if this is the fluid inclusion and if it is vapor rich, we are talking about vapor rich. Okay, vapor rich, then the diagram will be like this. This is your vapor and this is your liquid. This is your vapor rich fluid inclusion. Okay, where this vapor rich in the sense, this will be rich in vapor. Okay, always remember this liquid always present outside. Liquid is always present outside. In this case also you can see this is liquid water, then liquid carbon dioxide, then vapor carbon dioxide. We will see some diagrams also where we will where you will just get familiar with that, what are the relative positions of this liquid or the phases present inside the fluid inclusion. Okay, so don't worry about that. So which of the following situation most likely indicate boiling of the fluid? Okay, this is one mineral having x and y fluid inclusion. Okay, one is vapor rich, one is liquid rich, and if you just boil them, then what will happen? Okay, first option, x homogenizes to liquid and y homogenizes to vapor. You can see x is liquid rich, x homogenizes to liquid, and y homogenizes to vapor. Okay, this is right because it is liquid rich, so it will just get enriched in liquid. If it is vapor rich, then it will get enriched in vapor. But now you can see at different temperature and temperature of homogenization, this y homogenizes, that means that is the temperature of homogenization. So what is temperature of homogenization? Th, not this type of th, capital T. This is T, then small h. This is temperature of homogenization. Temperature of homogenization. So what is this temperature of homogenization? In, if we are considering various types of phases, whether it is liquid or vapor or solid, okay, then if we just change the temperature pressure condition, then the phase change will happen. Okay, phase change will happen. And when one phase is getting converted to another phase, there is one boundary in between, there is one boundary, and at this temperature where this A will be converted to B, okay, that particular temperature, that is called your temperature of homogenization. Okay, if I just consider this vapor and liquid, okay, they are of biphase inclusions. Okay, this vapor and this liquid. Now if I just want to find out the temperature of homogenization, you can see this is the boundary. Okay, this is actually the boundary between this liquid phase and this vapor phase. Now when this liquid vapor meniscus, this is called your liquid vapor meniscus. Okay, when this meniscus will vanish at that particular temperature, that temperature is called your temperature of your homogenization for this vapor and liquid phases. Okay, so at different temperature this answer is not correct. Both homogenizes to liquid, that is also not correct, because if it is liquid rich, it will become liquid rich during boiling, and if it is vapor rich, then it will become enriched in vapor. Okay, so this is also not correct. Both homogenizes to vapor, this is also not correct. And D option, x homogenizes to liquid and y homogenizes to vapor at the same temperature. At the same temperature, this is correct. X is liquid rich, so it will homogenizes to liquid. Y is vapor rich, then the Y will vapor, Y will homogenizes to vapor and at the same temperature. Okay, so why? Because when we are just considering this fluid inclusion studies, there are some assumptions. Okay, there are some assumptions taken. There are around 4 assumptions. So in this case, this D is going to be your answer. And this statement, the X homogenizes to liquid and Y homogenizes to vapor, this is represented by this reaction or this representation. If L plus of V, that is L, and L plus of V, that is V, L is your liquid Okay, V is your vapor, and this L is liquid, V is vapor. Now if liquid plus of vapor, they are during after boiling they are becoming a liquid, then this should be liquid rich. This should be liquid rich. And if liquid plus of vapor, that is giving rise to a vapor phase, then this is vapor rich. Okay, so till now no doubt this X will homogenize to liquid and Y will homogenize to vapor, because X is liquid rich and Y is vapor rich. Okay, so I think no doubt will be here. So then what are the other possibilities? In this case you can see this is the salt, that is the solid that will present outside, then liquid, then gas, then liquid. Okay, sorry, then liquid, then gas. You can see this is the gas. And if it is if it is expected to contain a vapor phase, then that vapor phase will remain inside it carbon dioxide. Okay, in this case we are able to see now, this is vapor carbon dioxide at the center, then outer periphery liquid carbon dioxide, then liquid water. Okay, you can see water is present outside, salt is present further outside, then your carbon dioxide liquid, then carbon dioxide gas. This gas means maybe vapor. Okay, so this is actually the sequence. If it is actually a polyphase fluid inclusion, then it will contain this outer periphery, there will be solid. Okay, and there will be your water will be there, then further inside your like carbon dioxide liquid, then further inside then vapor carbon dioxide. Okay, this is actually the sequence. And why this actually happens, why these phase changes, why these phases are arranged in such a manner? Okay, so after trapping phase changes happens. Why this phase change happen? Okay, now why this phase change happens, why phase change or changes, why phase changes? When this after trapping, okay, trapping the fluid inclusion, it can happen due to shrinkage. Okay, and these gradation, like outer this solid, then water, then liquid carbon dioxide, then vapor carbon dioxide, why this is happening? This is due to the shrinkage. And why this shrinkage, why this shrinkage is responsible for this various types of phases presence? Okay, because the volume coefficient of thermal expansion, okay, the volume coefficient of thermal expansion for most of the minerals is 2 or 3 times less than the volume coefficient of thermal expansion of water. Okay, let me tell you again. Okay, the volume coefficient of thermal expansion for most of these minerals, that is less than the water. Okay, that's why water is present always outside. And all these minerals, like these are also considered as minerals, their thermal expansion is that is less than the water thermal expansion coefficient of thermal expansion of water. So उसमें क्या होता है कि एंड ड्यूरिंग कूलिंग, दैट्स वाई ड्यूरिंग कूलिंग वट एवर द कैविटी ना, दैट कैविटी shrinks much less than the fluid inside. That cavity that shrinks much, okay, as compared to the fluid inside. And when this pressure of this inclusion, now inside it shrinked, okay, now its pressure, when the pressure of this inclusion that drops below the total vapor pressure of the system, total vapor pressure of the multi-component fluid, okay, a bubble will nucleate. Then क्या होता है कि a bubble will bubbl, a bubble will nucleate, and now this bubble will grow in size. Okay, now this bubble will grow in size. Now this total fluid inclusion is present in our sample. Now if we just want to determine the temperature pressure condition when this entrapment happened, Okay, or we just want to determine the different temperature of homogenization. Okay, when this maybe liquid vapor meniscus is vanishing, or this vapor carbon dioxide liquid carbon dioxide, that boundary is vanishing, or this liquid carbon dioxide or your water, okay, liquid water, that boundary is vanishing. These are different temperature of homogenization, and by using the concept of microthermometry we can accurately determine the particular age of your entrapment of your fluid inclusion. Okay, so what is microthermometry and what is the process of this microthermometry? So now I just told you that after entrapment there are three types of possible causes. Okay, one is your shrinkage, first is your shrinkage, and second is your that is your daughter mineral development or your daughter mineral. This is basically actually a solid phase. Okay, when your fluid inclusion is super saturated with something, maybe let some halide crystal or NaCl crystal, okay, it is super saturated, very saline water, then it will create or it will form your daughter mineral. And there is another third one is your metastability case. Metastability case in the next numerical, or maybe I will just explain about this metastability because it is also very important. Shrinkage is important for this type of different types of phase formation, and metastability, that is also important, very important. Okay, so then if after this entrapment of this fluid inclusion, various types of these phases, they just got separated, they just got separated. Okay, during cooling. Now we have this sample where your fluid inclusion, maybe liquid rich or vapor is that is present. Then if I want to determine their temperature of homogenization or entrapment age, then I will have to take the help of your microthermometry. And in microthermometry, what is actually the procedure? The procedure that tells that you have to first boil it, you have to increase the temperature, everything will be in one phase, then you will have to slowly, you will allow it to cool. And by doing that you will be able to see, or you will able to just distinguish or demark different temperature of homogenization between corresponding phases. Okay, phases. So microthermometry tells that you have to heat the sample. Okay, everything will be one phase. Okay, then you will have to cool it. Okay, first heating and cooling. And that's why in fluid inclusion analysis, that fluid inclusion thermo sorry not the not thermo microscope, we have one heating freezing stage. Okay, heating and freezing stage. And you can see this is the vapor, this is liquid water vapor, liquid carbon dioxide liquid water, liquid carbon dioxide. And if some liquid vapor carbon dioxide will be present, that will be present inside. And in this case you can see this is liquid water, vapor carbon dioxide, and liquid carbon dioxide. You can see liquid water is present this much of liquid water present, and liquid carbon dioxide then further, then this is the vapor carbon dioxide. And in this case these are your like this must be your liquid water. Okay, then this must be some this is your vapor carbon dioxide, and this is your solid. Okay, because this dark color, this is basically your halite. Okay, that is your NaCl salt. This is actually highly saline inclusion due to highly saline inclusion. That's why this intermediate phase, okay, super due to this super saturation daughter mineral formed. Okay, due to this super saturation daughter mineral formed. Okay, daughter mineral formed. So I hope in this video will help you to understand this these things. Okay, so thank you very much. Thank you very much, and save our mother earth. Always plant trees, go green, Thank you. And if you are preparing for any geology examination, competitive examination, and if you're interested, if you like this video, then do subscribe, do share. And if you want to join, then these are the numbers you can contact. This middle number, this is my number, and this is our mail ID. Sorry, this is our mail ID. You can put a mail to this mail ID also, and there will be a link tree given in the description box. By clicking on that, you will be getting access to all our social websites, and do visit our website. Okay, and for more information, and there is, if in this YouTube channel also, you can go to the about section of our Ask Geology, and below all the social media platforms, social media link are shared. Okay, so you can just uh, come reach us by clicking there also. So thank you very much. And